Problem 7 says the limit as x approaches infinity. Now the key on these ones are, when you're approaching infinity, it means you're going to be really, really, really big numbers, as you're putting in really, really big numbers for x. And so we had learned in class that what you want to identify in these problems is so you want to identify any horizontal asymptotes. Okay, that's your goal. Now, in this particular problem, if you look at it, what we learned in class about identifying asymptotes is if it's top-heavy, it's either top-heavy or, what I mean by that is the top, the biggest degree on the top and the degree on the bottom, it looks like the degree on the top is heavier, it's bigger, so we call that top-heavy. And that means there is no asymptote, no horizontal asymptote, okay? There's no horizontal asymptote. Okay, so that means this thing doesn't have like a line that it's going to come up and flatten up against. It does nothing that's preventing it from going really, really high or really, really low. So right off the bat, we know our answers are either going to be infinity or negative infinity, or maybe it doesn't exist at all. We'll see, okay? So let's go from there. So in this problem, I think that the way to get the right answer is to look at this and say, all right, if I put in a super big number there and a super big number there and square it, so even if I put in a super big positive number to the fourth power, it's going to get bigger and bigger and bigger and bigger. So it's going to be like, imagine that, versus on the bottom, this. So clearly the infinity to the fourth is going way bigger than infinity squared. So it's sort of heading towards, so that sort of means it's heading towards infinity. But if you look carefully, there's a negative. So the answer to this one is negative infinity. That's the limit. So really, that doesn't exist. Limits that head to infinity don't really exist, but you can at least identify where it's going. It's heading to negative infinity. That's not really a limit in the sense that the limit is 5. So infinity is not really like a solid number like 5. Okay, so I'm not going to repeat the stuff I just said for problem 7, but again, this is a limit that goes to infinity. Once again, the degree of the numerator versus the denominator is bigger, so it's top-heavy again, which means there is no horizontal asymptote. So this thing is free to grow or to shrink in any way it wants. So I'm going to imagine putting in, as x approaches infinity, I'm going to imagine sort of putting in infinity squared over 4 times infinity plus 1. It kind of feels like the top is getting bigger, bigger, bigger than the bottom is, right? So I think it's going to end up being infinity, but then look out for the negative that they put at the beginning, and there's the limit for this problem, negative infinity. Now, that does not exist, technically, but you can at least identify where it's going, so you should do that. Okay, number 9 here, again, it looks like it's sort of top-heavy. We're heading towards infinity. X approaches infinity, so if you just put it in, 3 times infinity to the 4th over 2 times infinity squared plus 2. It looks like the top is just growing because it's to the 4th power. It's really going to just explode and go way higher. And so the answer is just infinity. That's the limit. It's going to get bigger and bigger and bigger.